Hello, this is checkpoint 3.42 from section 3.7. Here they want us to use the inverse function theorem to find the derivative of this function. G of x is equal to 1 over x plus 2. And they want us to compare the results by differentiating this function directly. So let's first find the inverse, or use the inverse function theorem. And for that, if we want the derivative of g of x, we need to find f inverse. So let's first find f inverse of x, or in this case, g inverse. And we do that, if you remember, by setting y equal to 1 over x plus 2. And we want to solve for x and then switch to x and to y. So we solve for x. We'll say y times, let's just do the cross multiplying business. So yes, that's going to be it. So it's going to be xy plus 2y. I multiplied that on both sides. This is equal to 1. And we'll factor out. We don't have to factor anything out. We just need to take the x, solve for x here. So it's going to be xy is equal to 1 minus 2y, and then divide by x. So x is equal to 1 minus 2y divided by y. And then if we switch the x and the y, we will get g prime, since this is a g function. We're going to get g inverse of x is equal to 1 minus 2x divided by x. So this is our function. Now we want the derivative of that according to this. So let's say g inverse prime of x, and we'll use the quotient rule. Low times the derivative of the high minus 2 minus the high, that's 1 minus 2x, times the derivative of the low, which is 1, all over low squared, x squared. And then we will have minus 2x minus 1 plus 2x all over x squared. So this will give us negative 1 over x squared. Okay, so that's g inverse prime, and that's where we are now. And then we want to find out what happens when we put the original function, which is 1 over x squared, in for this. So we'll say g inverse prime of g of x is going to be negative 1 over x squared, but instead of x, we're going to have g of x, which is 1 over x plus 2. So this is just negative 1 divided by 1 over x plus 2, and the reciprocal of that, x plus 2 squared, so it'll be x plus 2 squared with a negative. And then finally, the derivative, g prime of x, is going to be 1 over this thing that we just found, negative x plus 2 quantity squared. All right, that is it. So this is our answer for the derivative of g. Now let us try to find the derivative of g directly. Let's rewrite g of x is equal to 1 over x plus 2. We have gone over the chain rule, and this is just a reciprocal. So you can do this using the quotient rule, but let's try something different without taking the derivative yet. Let's rewrite this as x plus 2 to the negative first power. Now we'll take the derivative of that using the the chain rule and the power rule, extended power rule. So g prime of x is going to be -1 x plus 2 to the -2 power times the derivative of the inside, the chain rule, but that's just equal to 1. And if we rewrite this, g prime of x is equal to -1 divided by x plus 2 quantity squared. And we'll see that that matches up. So that's correct. So this is obviously easier, but the idea behind the inverse function theorem allows us to find the derivatives of functions of inverses. So, okay, I hope that helps.